Greetings and welcome, all of you great big beautiful Quantslobbers. I got to start this edition by asking, is there anything that conveys the sheer grandeur of this channel better than having that big Quantslob right there pop out of your screen coming at you like that at the beginning of every edition? I mean, look at that. It gives me goosebumps. I'm sure you can tell I'm feeling it right now. This time around, we're going to kick off our basic application series. We just wrapped up our Quantslob foundational series, and since there's no better way to know where you're going than to visit where you've been, so a super speedy recap. We covered a ton of ground in the foundational series, all the way from a discussion on how to approach scientific problem solving to statistical populations, to an introduction to terminology and symbology, and we closed things out with a big time discussion on probability, and we covered a lot more topics along the way through the whole thing. If you haven't already, and if you're really interested in familiarizing yourself with stats and data science from the ground up, I strongly suggest you check out the foundational series. The series has been playlisted, and I think the entire playlist runtime is well less than an hour and a half. Another reason for checking out the foundational series is that we're going to make use of some of the examples and setups in future installments. Many people think of stats as one volume after another of methods, equations, techniques, and for this reason, it may surprise a lot of people that learning the art of statistics really involves a fairly modest handful of conceptual milestones. Understanding statistical populations is big. Probability, sampling distributions, continuous attributes or variables and their distributions, statistical tests, that is testing an assumption, for example, comparing an observation or experience against a sampling distribution, just as an example. This idea of testing or comparing assumptions with observations plays out throughout science. Whether we are experimental designers charged with the responsibility of determining whether a bolt-making machine is working properly, or we're AI engineers building a reinforced learning algorithm for a robot, the basic idea is the same. Now, the face of these concepts may be a little varied from one application to another. For example, in AI, we may use, or the robot may use, an empiric distribution of past robot behaviors rather than a probability sampling distribution. The idea is the same. Where are we headed? Probability sampling distributions. And I want to say as a heads up, with probability sampling distributions, we're not going to discuss or spend a whole lot of time with how they're calculated. We're saving that for later. Plenty of time for that later. We're going to focus on something much more important. We're going to clarify what they represent, and we're going to focus on looking for patterns in their shape, distribution, and variability. Hypothesis tests, statistical tests of parameters, including some examples of applied hypothesis tests. That is going to do it this time around. Thank you very much for tuning in, and don't forget to stay tuned for more Quantslob.